In this video, we're going to look at a new reaction of haloalkenes. We're going to tap into a lot of our understanding of what makes for a good reaction of haloalkenes, and actually see how some of that, while it's very true and works really well for the SN2 reaction, actually is almost opposite in many ways for this new reaction. So what I want to start us off with is recalling that if we look at a result from before, so let's recall that if we take our typical haloalkene and react it with sodium, I don't want to draw a line there, NaOCH3, we would get this molecule, okay? And you could draw curly arrows for it if you need to, but it's an SN2 reaction. Now, if we do the exact same thing, but we add two additional substituents, now we have a tertiary haloalkane. And if we have a tertiary haloalkane and we react it with the exact same nucleophile, we try to do an SN2 reaction with the goal of producing this product, we would actually see that this reaction does not occur. No reaction. Okay, so what's going on here? Well, it's all about the structure of the haloalkane. So it's two hindered / substituted. And as a result, we will see no reaction occurring. But what if we change the reaction conditions such that we have, so let's make a change. Let's make a change so that we have, instead of NaOCH3, we have HOACH3. And this is just the molecule methanol, like ethanol, except with a methyl group instead. And we mix those together. Maybe we apply some gentle heating, but for the most part, it's very similar to what we did before. What we actually see is that we form a substitution product. Now, what was different about this reaction was, well, many things, but the first thing to take note of is we changed the nucleophile. So instead of NaOCH3, we had HOACH3. Furthermore, we changed the solvent. We changed the solvent from whatever it was above. I didn't label one, but acetone DMSO, to HOCH3. That is to say that methanol is the solvent. So this is a reaction where we see the reaction or breakdown of our haloalkane, right? It's gone. It's sort of lysed or, decomposed by the solvent, where the solvent is both the nucleophile and the solvent. So what we call this is actually called a Solvolysis reaction. And I'll define Solvolysis on the next page. So Solvolysis reactions are reactions in which solvent participates in the reaction to ensure the reaction is efficient. Okay. What I want to do is just briefly go over the additional product in the reaction. And then we're going to stop and call this the solvolysis video before we go on to a more detailed look at this reaction, which is the SN1E1 reaction. So another product that forms and that is this molecule. Okay, so again, to recap, what we did was we took our haloalkane and we mixed it with methanol, which is also called MEOH, and we formed two products, one of which was a substitution product, and the other one was this product, which is an alkene, and so this is an elimination product. So we have a substitution and elimination product being formed in the solvolysis reaction. Now what we could do before we break is just look at one more example of this, but other alcohols could be used in solvolysis reactions, but not many. We could even change up the haloalkane. Now, don't worry if you can't like predict the products. This is an example of an SN1E1 reaction, which we're going to look at in a lot more detail in the upcoming lectures. I just wanted to give you some context for what a solvolysis reaction is. It's kind of awkward because it's really an SN1E1 reaction. That's what I care about you knowing, but people also call it a solvolysis reaction. It's a nice way, though, to introduce this concept to us. So we could replace the substrate with something else that is highly hindered. It's a tertiary haloalkane, no SN2. And then what we do is we replace our methyl group that was part of our earlier reaction with now an ethyl group. Okay, and so that's one of the products. That's our substitution product. This is our elimination product. Okay, we're going to look at this in a lot more detail in the upcoming lectures. This is an example of an SN1E1 process. It's specific for some particular examples. What I want you to take away from this is there's a new reaction on the horizon. One example of it is the solvolysis reaction. Additionally, even though these highly hindered substrates cannot undergo an efficient SN2 reaction, they can do other things, this SN1E1 process. Okay, so again, short video, just quick introduction to solvolysis reactions and SN1E1 reactions.